Okay, let's continue. So please try to perform the exercise on the order of precedence by yourself. We have three cases. So A, B, C, and A 3 over 4 times 6 times 7 square plus 4 to the power of 5 divided by 7 square minus 145 and so on. I actually posted the results on the bottom right corner of the slide. Please do it by yourself and compare the result to this, okay? Next one, assignment operator. So in Matlab, the equal sign is actually called the assignment operator. So usually the statement will be something like this: variable equals to a value or a computable value. Okay. For example, x equals 2. So please see on the screen on the right, x equal 3. Okay. So x. So now the variable x will be assigned a value of 3 by Matlab. Okay. If we type x equals to x plus 5, so now x will be 8. Okay. However, x plus 4 equals 30 is not correct. Okay. Error size will come out because x is 8 plus 4 is 12. So this one is, the statement is not valid. So next, please do this example by yourself. Let's say the volume of a sphere is given by this formulation: V equals to 4 pi times r cubed divided by 3, where r is the radius. So use Matlab to compute the radius of a sphere given the volume of a sphere having a volume 30% greater than that of a sphere of radius 0.3. So what does it mean? So at first you guys have to actually calculate the volume of a sphere of radius 0.3 meters and then you actually use that value in times 130%. Okay, so the result of the new volume will be used to calculate the new radius based on the original formulation between volume and radius. Okay, as you can see on the bottom right, so the new r is actually equals to 3 times v new divided by 4 pi to the power of 1/3. So the result will be 0.3274. You guys should try to do this at home. Okay, so how do we make new variables? So the rule of thumb is to always start with the letter and should be less than 63 characters long. Okay, it can contain letters, digits, underscore. So you guys can actually name some variables like practice or practice underscore 1, something like that. Okay, and try not to use something very long, more than 63 characters, and try not to use something that, you know, upper and lower case sensitive, because Matlab is case sensitive. So this means capital A and normal A's are different. So please, you know, select other names, and also try to avoid using names similar to built-in function from Matlab. For example, sine, cosine, exponential, tangential, square root, and so on, or maximum, minimum, summation, determinants, and so on. These are reserved for Matlab's operations. So whenever we use, the errors will come out. Okay, these are some useful commands to manage your work session. For example, you can use CLC. Actually, it helps to clear the command windows. Sometimes the command windows are very cluttered. Okay, you write after you use so many calculations, it will be very difficult to see. So it's actually very good to clear the command windows once in a while. So next we have clear. So when we use clear commands, it will remove all the variables from memory. And if we just want to remove some of the variables, for example, variable 1, VRA1 and VRA2 from the memories, then you use the clear space var1, var2. So it will erase only these two variables from the memories. Okay. And other commands actually like who and whose, so it will list all the variables currently inside memory. Okay, so this also we have colon. So actually colon is very popular in Matlab, so it signifies an array. Okay, comma, so we can actually separate the elements of an array. Semicolon, so this one is important. It actually helps to suppress screen printing. Okay, so if we have this semicolon at the end of the sentence or at the end of the command, the result of that command will not be shown. Okay, so 3 dot, actually if we put 3 dot at the end of the sentence, then it will keep the next line as only one line. So this one is very useful, especially when we want to write a very long command and it cannot be fit in just one line. So we use these 3 dots at the end of a line, so to signify the continuation to the next line. Okay, so A and S, actually I have mentioned to you guys before. So EPS is actually the accuracy of floating point precision. IJ we actually use for imaginary units. Okay, INF is actually infinity, NaN is actually undefined numerical results. So sometimes if we make the calculation, it's impossible to calculate, then this result will come out NaN. Okay, pi is actually the number pi, so 3.14159 and so on. Okay, so next one, functions. So functions, as I have mentioned before, function needs arguments. Okay, for example, plot is a function to plot something. So x is the argument, so x is the variables that we want to plot. Okay, clear or clear x. So clear is a function, so we want to clear the variable x from memory. Okay, next one, complex number operations. As you guys know, the complex number we can apply many different kinds of operations for those. For example, addition, multiplication, subtraction, division, complex conjugate. So these are the example. Please try to do this one on your Matlab at home. Okay, this one actually very easy to do. Next is formatting. So if we type the format short, so this is the current default for Matlab settings. So if we put format long, so it will display 14 decimal digits. If we use format short E, then it will become 4.1429E plus 001. So what does it mean? So this means 4.1429 times 10 to the power 1. So actually it equals to 41.429. Okay, this is scientific with 4 decimal digits. Similarly, we have format long E, so it will be scientific with 15 decimal digits. Or we can use format bank. So because bank is actually the least number that we can take is 1 cent, so only 2 decimal digits. Okay, This one I have actually introduced you to you guys before. So we have menus, we have toolbars. Okay. Matlab is actually very strong in computational capability, and it can be used to solve many engineering problems. So one of the most important components of Matlab is actually the arrays handling. So basically an array is an order collection of numbers, okay? And all the elements of the array must be separated by commas or by spaces. And we can use length function to determine how long or how many elements inside an array. For example, please try this example. So you from the first example, so we will have the array from 0 to 10. Okay, the space between them is actually, or the increment is 0.1. So what does it mean? We have an array from 0, 0.1, 0.2, and so on until 10. Okay. Okay, so this is the example. So this time I will put the array u equal to 0, an array from 0 to 10, the increment is 0.1. I can choose to suppress screen printing or not by putting the semicolon at the end. Okay, at first I will not suppress the screen printing. So we'll see the U array will have 101 elements. Okay, the same thing. If I do the same thing, but I put the semicolon at the end of the sentence, so the result actually the same. Okay, but it will not write the result onto the screen, which is much easier and much cleaner. Okay, and I can actually get the element number 7 from the array U, so the result will be 0.6. Okay, because it starts from 0, so the number 7 will be 0.6. Next one, polynomial roots. So this one is actually very useful commands in Matlab. Okay, basically it will help you to get the root of a polynomial equation. For example, let's say you want to get the root of this equation, 4x cubed minus 8x squared plus 7x minus 5. So this is what you should do. You should at first define an array A which contain all the coefficients. For example, in the case will be 4 minus 8, 7 minus 5. And next, please type in roots A. So the result will be, there will be 3 roots. Okay, we have only one real root, the other 2 are imaginary roots. So you can try to replace the x using the real roots and see whether the equations come out 0. Actually it's exactly 0. Okay, except we have some very small errors like 10 to the minus 5 or 6. So this is the result of the polynomial roots finding. So do we have 3 roots? The first one, the real one, is 1.388. The other 2 are imaginary. So this is the result coming directly from Matlab. Next, please try these built-in functions from Matlab at home. So we have sine x, actually is cosine. So sine, cosine, tangential, cotangential, exponential, log 10, square root, absolute. So these are very common. Okay, so remember, for the sine, cosine, tangential and cotangential, all of the arguments will have to be in radians, okay, not the normal degrees. So you guys have a lot of practice. Please submit this one in 5 days. Okay, we have problem 1, 2, and number 2 is actually a lot. So please submit this one by yourself. For example, problem number 1, suppose x take the value from 1, 1.2, 1.4 to 5. So x is an array. Use Matlab to compute the array y, which have the function y equal to 7 sine 4x, and determine how many elements in the array y and the value of the third element in the array. So those who can complete this one, please send the list of your commands that you use to me, okay, and with your name and student ID, so that I know who submits. Okay, so the deadline will be 5 days from now. Okay, please consolidate Blackboard for the actual deadline for the assignments. This is the end of this lecture. Thank you.